Welcome to Electrical Engineering with Excel. This video is about the development of a spreadsheet that does the calculations for the passive components for a two-pole Sallen-Key low-pass filter. It uses the formulas we derived in the Sallen-Key component selection video. In the last video, we derived some equations to calculate component values for the Sallen-Key low-pass filter. It was a method using the geometric mean of a capacitance value, then having both capacitors set to standard values right off the bat. The ratio of C2 to C1 was then used to determine the ratio of R2 to R1, and standard values are chosen from the results. The spreadsheet we are developing will do all these calculations with ease. The development of this spreadsheet encompasses several techniques covered in numerous previously posted videos. The LM117/LM317 voltage regulator calculator covered cell styles, cell names, sheet protection, and more. It also dynamically linked component value labels in the schematic to the associated calculated cell. The E-Series user-defined function developed Visual Basic for applications code to return the closest standard component value from the various E-Series values. We also developed code to return the SI engineering prefix for a given value. It scaled the number accordingly and returned the number as text with the associated SI prefix. We developed a variation of that function for capacitors that does not return nano or milli. All these user-defined functions are already loaded in this workbook we are about to make. Another spreadsheet was developed to select standard component values, the SI prefixes with units, including the D-rated next highest power rating of resistors. We made Excel work in the Laplace S domain, where we made Bode plots for a simple network. We will use this methodology to make Bode plots for this Sallen-Key filter using the standard component values calculated. If you haven't watched these videos, most of the spreadsheet application we will lay out in this video may not be obvious. Some new features will be introduced, starting with a drop-down selector for the desired E-Series component values for the resistors and capacitors. Also, the scroll bar control will be used to adjust the C2 and C1 values up and down to find the best selection that results in closer to target values. One thing I want to point out about the scroll bar control is the minimum incremental change is 1. We want to make the C1 upscale to range from 1.1 to 5. So we will make the scroll control output values from 11 to 50, and then we will divide that by 10. For the C2 downscale, we want the value to range from 0.9 to 0.2. So we will make the scroll control output values from 90 to 20. Then we will divide that by 100. Let's go to the spreadsheet and get started. I already have a lot set up in the spreadsheet, including the input section and the output section, which I assign their associated cell styles. I have the schematic with dummy text box labels for the component values and reference designators. I have the nominal capacitance cell set as a specification cell style, which is protected. Over to the right, I have what I call a construction zone. It contains values for the component series lookup for resistors and capacitors, scroll bar lookup references, and a place to construct the schematic component value labels. Excel doesn't usually come with the Developer tab enabled. If you don't have it, right-click on any existing tab and select Customize the ribbon. Then check the Developer box and press OK. Then from the Developer tab, select the scroll bar Form Control. Then draw a rectangle to the right of the C1 upscale cell. Then right-click and select Format Control. As previously mentioned, set the minimum value to 11 and the maximum value to 50. On the Protection tab, uncheck the lockbox. Then set the cell link to AA2 in the construction zone which I have named underscore C1 UPSB, and press OK. Set the C1 upscale cell to be equal to the underscore C1 UPSB, then divide by 10. Now the scroll bar goes from 1.1 to 5. Now right-click on the scroll bar and copy it to the next cell below for the C2 downscale. Select Format Control and make the minimum value 20 and set the maximum value to 90. Then set the cell link to AA3, which I have named underscore C2 DWNSB. Go to the C2 downscale cell and set it equal to underscore C2 DWNSB and divide by 100. The scroll bar will range from 0.2 to 0.9. I'll add a couple spaces to the adjust label to center it above the scroll bars. Now let's make the drop-down selector for the capacitor series. From the Data tab, select Data Validation, and from the Allow section, select List. Then make the source be the component series lookup from E12 to E96. You can widen that list if desired. Then press OK. Now you can see the list is in a drop-down box. Now let's do the same with the resistor series, allowing a list once again. Going back to the construction zone and selecting E12 through E192. I'll go ahead and select E96 for the resistors. Now we will use XLOOKUP to return the series number from the series lookup table. The lookup value will be the capacitor series drop-down cell. The lookup array will be the component series E3 through E192. The return array will be the series lookup number column. Now do the same with the resistor series. I'll copy the capacitor lookup formula and just edit the lookup value to be R series. Ignore the error on the cell. It thinks I'm omitting adjacent cells, and that's right. I'll start using the various user-defined functions. From the Developer tab, select Visual Basic or Alt F11 to show the Visual Basic editor. I've already loaded the cat prefix code in the editor, along with the eSeries function and the engineering prefix function. I'll calculate the geometric mean capacitance, which is the nominal capacitance divided by the square root of the corner frequency. Then the formula for C1 is the eSeries function of the C1 upscale times the geometric mean capacitance over zeta. The series number from the construction zone is named C series. C2 will be the same eSeries function using the C2 downscale number times zeta squared times C1. With the series number being C series. I'll set the format of the capacitance values to be in engineering notation. Now the ratio of C2 over C1. I'll leave it as the general number format. I'll also type out the formula for R2 over R1. Then the product of R1 and R2. The formula for R1 is easy since we already have the products and ratios. And then the formula for R2. I'll now make these standard components using the E-series function and using the R-series number. I'm moving the resultant formulas out to the right temporarily so I can see the editing, and typing the formulas. I'll leave them with the general number format. I'll move the equations back to where they were. We will now make the formulas for the schematic component labels. For R1, that will be the engineering prefix function of R1 concatenated with omega. Then the same for R2. For C1 and C2, we can use the cap prefix function. I'll center up the labels a bit and make sure they are center justified. I decided to move the resultant value section up higher so that it can be easily viewed when making the scaling adjustments to C1 and C2. I'll protect the sheet. Notice that I can't adjust the scroll bars now. That's because the cells linked to the scroll bars are locked by default. I'll assign them to the input cell style and make them unlocked. Now when the sheet is protected, they work. Watch how tweaking the scaling makes the resultant value hit very close to their target value. Now I'll unprotect the sheet and hide the construction zone and get rid of that silly sign. Let's turn off those ugly grid lines and finally protect the sheet. I decided to add a resultant Bode plot to the spreadsheet. Here's the transfer function with a magnitude plot and a phase plot. Go check out the Using Excel in the Laplace S-Domain video. I point out in that video how, at least for me, it's easier to form the nested imaginary functions using the number 1 for the coefficients at first, then place the coefficients in later. I hope you found this useful. Thanks for watching. Please click the like, subscribe, and notification bell so you don't miss any upcoming content.